This is our video for 12.3 day 2 notes. We're still looking at indeterminate forms when the limit produces 0 over 0, but specifically we're going to look at limits of functions where the polynomial has a degree greater than 2. And when that happens, we're going to use synthetic division to break it down, factor more, and be able to cancel. So for number 1, we can see that this function does have a polynomial with a degree greater than 2. The degree is actually 3. So what I'm going to do before I can do synthetic division, I'm going to just factor anything out that I can. So the numerator I'm actually going to leave alone, but the denominator I'm going to factor out of 4. So what we're hoping for is this factor of x minus 2. We're hoping that the numerator also has a factor of x minus 2 so that they'll be able to cancel. So that's where our synthetic division comes into play. We're focusing on this x minus 2. So little refresher on synthetic division. If I set that equal to 0, then the x value is 2. So that's what I'm going to be using for my value in synthetic division. So my coefficients for the numerator are 2, -7, 8, and -4. So remember, drop down the first term. Then we multiply, so 2 times 2 is 4. Subtract, -7, we'll add in this case, -7 plus 4 is -3. Then -3 times 2, -8, add down, +2, 2 times 2 is 4, add down, we get 0. So now what happened is we just factored the top. So this is what we have at the moment. We factored out the x minus 2, and we are left with 2x squared minus 3x plus 2. And we have the 4 and the x minus 2 in the denominator. So we got what we were hoping for. Those x minus 2's are now going to be able to cancel. So the problem that was creating that 0 over 0 issue is gone. So you don't necessarily need to keep factoring at this point because the issue is gone. So now you can try direct substitution again. So now what we're left with is the 2x squared minus 3x plus 2 over 4. Try direct substitution, and as long as you don't have any issues, you're fine. So it looks like when I substitute 2, I'm going to get 4 over 4, which is 1. No issues, so the limit is 1. All right, looking at example number 2, before we jump right into synthetic division, we do want to notice that we have a polynomial greater than 2 in the numerator, and I want to try to factor out and simplify anything that I can before I start. So I'm going to leave the numerator alone for now. And in the denominator, I can tell that that's difference of squares. So that's going to be factored into an x minus 3 and an x plus 3. So the issue that is causing the 0 over 0 is going to be this x minus 3. Because if I substitute -3, that's where the 0 comes from in the denominator. So we're hoping that that x plus 3 will have something to cancel with in the numerator. So when it comes to synthetic division, this is the factor that we want to worry about. So I have -3, and my coefficients are 5, 14, -2, 0 placeholder, and then -9. And then we're going to go through that should be -1. All right, there we go. So now off to the side, I'm going to show us what we have now. So we factored out an x plus 3 in the numerator, and we are left with 5x cubed minus x squared plus x minus 3. In the denominator, we have the x minus 3 and the x plus 3. And we're in good shape because those x plus 3's are going to cancel, and that's what was causing the problem of 0 over 0. So since the problem's gone, you do not need to keep factoring unless another problem arises. So at this point, you want to check direct substitution again, because if it works, then we're in good shape. And it looks like when we plug in 2, we get 25, so no more issues. Number 3, we have a polynomial in the denominator that has a degree greater than 2. So this is where we're probably going to be using synthetic division. I do want to point out, some of you might recognize that this is the sum and difference of cubes. If you recognize that and remember how to do it, feel free to just do the sum and difference of cubes. But if you don't recognize it, synthetic division will work in this case. So I'm going to start to do any factoring that I can. So the numerator looks like difference of squares. And then in the denominator, let's pretend we don't recognize the sum and difference of cubes. So the issue is being caused with this x plus 2 in the numerator. That's where a 0 is coming from when I plug in negative 2. So we're hoping that there's a factor of x plus 2 in the denominator as well, so that we can cancel those out and get rid of our issue. So that's the factor that I'm going to use for synthetic division. So the value is negative 2, and then my coefficients are 1, 0 placeholders, and then 8. And here we go with synthetic division. All right, so what we have now is that x minus 2 and x plus 2 in the top. In the bottom, we did factor out the x plus 2, and then we are left with x squared minus 2x plus 4. So the x plus 2's are going to cancel, and we are now left with x minus 2 in the top and x squared minus 2x plus 4 in the bottom. So now try direct substitution, because if you don't have any other issues, then you're fine. So when I substitute negative 2 in here, it looks like I get negative 4 over 12, which is going to reduce to negative 1/3, so no more issues. There's your limit. And the last example we're going to do is skipping to number 7. And I realized I haven't been mentioning that you should still be checking to make sure that you get 0 over 0. So try direct substitution first. We get 0 over 0, and that's the issue. So my numerator has the polynomial with a degree greater than 2. So let's see if we can do any factoring with the denominator at this point. So I'm going to leave the numerator as is. And my denominator will factor with an x plus 1 and a 5x minus 7. Now here's a little hint. We know that we're producing 0 over 0, so we know that there's a factor in the numerator and denominator causing 0. So if you're trying to have a little shortcut with factoring, and you know that the limit is approaching negative 1, that means you're going to need a factor that creates 0, which would be x plus 1. So that can be sort of like a starting spot when you're factoring. All right, so we need a factor of x plus 1 in the numerator. So now we can go with synthetic division and use negative 1. My coefficients for the numerator are 2, 0 placeholder, 4, and 6. All right, so what we are left with in our numerator, we have our factor of x plus 1, and then we are left with 2x squared minus 2x plus 6. Denominator, we have our x plus 1, and then our 5x minus 7. So those x plus 1's cancel, so the problem is gone. That 0 over 0 issue is no longer the case. So try direct substitution, and it looks like we get 10 over negative 12, which would be negative 5 over 6.